All right, so in the last section, we significantly increase the speed by which our neural networks train. So even in the last section, seeing something in the realm of 1,500 reviews per second on our test data. I mean, just absolutely screaming. Now, in this section, we're going to kind of go back one chapter and continue to try to reduce the amount of noise that our network has to go through and increase the amount of signal. This like signal to noise ratio, the more that you can do to help the neural network cut through, the really obvious stuff so that it can then focus on the really difficult stuff, the better your neural network will be able to train. And that's really what we want to kind of continue to iterate. So as we, once again, this is about framing the problem so the neural net can be as successful as possible. As we've already seen, a few relatively small changes can have a drastic impact on how fast the network trains, how much it's able to identify the underlying pattern that you care about, and we're just going to kind of continue to iterate. So in this section, we're going to go back to and say, okay, what is our neural network doing? This is the question that we're always asking, right? So what is really happening under the hood? So this is right now we're adding these vectors together. That's computing this vector, and that's making a prediction, right? So this ends up being a sum of all the words that exist in in the uh, in the review. Now, it's kind of funny. Earlier, when we were doing a small little validation of our of our idea, right? What did we do? We created this ratio where we identified what words were really important, what words had the highest correlation. Flawless, superbly, perfection, or unwatchable, pointless, atrocious, redeeming, laughable. And it kind of got me wondering, well, what if we use these to help continue to sort of weight it more in favor, where it's like, hey, neural net, look here, right? Like, it's okay if you look at other places too, I suppose, but like start with this, at least at very minimum. Or if we just actually said, hey, this is where the gold is, start digging. Not every one of these words seems like it's perfect. I mean, I don't know, bull and you and seagull or seagal. I guess it's that's too bad. Seagal is one of the worst negatively correlated terms. Don't tell him. But yeah, and here like Gandhi, like that's probably just a movie about Gandhi. I don't know if it really tells you much about the sentiment. So flawless, superbly, perfection. These are the ones we want the neural net to find. But this is clearly like if you're thinking this is, you're digging for gold. This is like a really gold-rich section, right? There's still some rock and some iron and stuff in here, but I mean this stuff right here. This is what we want our neural net to be naturally finding. So how can we actually use this statistic to help it do that? Would that even make sense to do? Um, well, what if we did a cutoff? Would that actually work and actually limit the vocabulary? Well, to investigate that, we actually want to see what the distribution is on this ratio. Now, for that, visualization libraries are great. So check this out. This is our ratio. 0 was totally neutral in the frequency of kind of this distribution, right? So we had it's normalized, but there's a ton of words that are kind of ambiguous. They're not really positive, they're not really negative, they're kind of in the middle. And then over here, there's actually a relatively small number that are just real punchers, like the ones that really, really, really matter. And to me, this is great because if these ones don't really matter, right? If this is the A, the periods, commas of the world, and they happen all the time, then I can get rid of these and it's going to save me tons of computational time because these are really frequent, but it shouldn't affect quality negatively. In fact, if anything, it should affect quality positively because they don't have that much predictive power. So we have a ton of words in our corpus that don't have predictive power. So let's get rid of them. That's just going to make our neural net that much stronger. Now, before we quite jump there, let's look at one more distribution. This is the relative frequency of different terms. It's called a Zipfian distribution normally. Our corpus is so extreme that there are a few terms that dominate. I mean, like, these few words are just way more frequent than all the rest. Like, look at that. And to me, this is interesting. And actually in natural language processing, a common trend is to eliminate the stuff that's both most frequent and the stuff that's most infrequent, right? The stuff that just almost never happens. Why? Stuff that's really frequent, like the, a, and, it happens so much that it doesn't really give you much signal. Stuff that's really infrequent, if it only happens once, that's not a pattern. That's just it happening once. How can you say that that's correlation when if you only see it one time? So people tend to kind of trim from both sides in natural language processing when they're trying to make a classifier that does something really interesting. So what we're really doing is we're looking at these kind of broad visualizations to say, hey, what is signal and what is noise? And can we use these different metrics to cut out noise and add in signal? So in here, I'm looking at this and I'm going, big chunk of noise right here, extremely frequent and not very useful. I'm going to cut this out. And I'm looking here and I'm going, yeah, there's a lot of stuff in here too. Now I think these are actually, this big part is going to be in here. And I think this is actually a better filter for getting out the really frequent stuff. But as far as this stuff that you can't even see it because it's so infrequent, I think we're going to try to carve that out too. So project 6 I'm really excited about. This one's great. Project 6 is going to be about making learning faster by reducing noise using these statistics, these ideas, right? There's no general neural net rule that says that this is how you have to do it. What we're doing is we're framing the problem to make the correlation as obvious as possible to the neural net so that it has the best chance to ignore noise and to find signal. That's what framing the problem is all about. So in the next project, what we're going to do is we're going to install these metrics into our neural net. So I want you to go ahead and give it a shot. See if you can build a neural net or modify this so that in the either train method or the sentiment network method, you put in a parameter that says, how much of this to carve out. You put in a parameter that says, hey, get rid of all the words that are too frequent or infrequent, right? And you have a min count, it has to, each word has to show up at least 10 times, at least 5 times to be included in my vocabulary and to be included in my neural net and see how that goes. So take a crack at that, and in a minute we'll pull up one that works and talk about it. So I'll see you there.